to the third exercise session of mathematics. So as per usual, now on the first 2 pages you can find a theory overview, which you can read through at your own leisure. Basically, it goes over about all the things I will be explaining in these videos, so if you want a quick refresher, you can always read through it. And then what's a bit special about this exercise session is, because I know it's tricky to sometimes find the answers for especially these kind of questions on Wolfram Alpha or on the internet, at the end I provided solutions to each of the questions. I'm not going to do this every time, but you can look through them. These should be right as solutions. Of course, it's always possible I made a mistake. In that case, don't doubt yourself and just tell me. Okay, so let's get started. And this exercise session, it's really all going to be about functions and investigating functions and mainly their sign. And then also a bit more about their behavior. So let's get this started and start maybe with 1b. So exercise 1b, where y is equal to x minus 3. And here I've asked you to investigate the sign of this function. So what does this mean? Well, it means for what values of x are you going to get a positive value for y, and what values of x are you going to get a negative value for y. And for this, let's have a look at functions a little bit more closely. That was really slanted. Okay, a bit better. So imagine x and y. Well, one of the only ways a function can change its sign is by crossing the x-axis, right? So here it was negative, all of a sudden became positive. And then it can go down again, and then here it becomes negative again, it can go up. And then for here it's all positive, right? Well, this is one way and this is right, and this is actually what we're going to be looking at first. Because, well, if you see, well, we're really interested in these points over here because they tell us, well, anything in between there, well, the sign has to change. So it goes from a negative to a positive, and then from a positive back to a negative, and then it becomes positive again. And that's very, very true. But there's also another way that functions can change its sign. And I'm just going to write it down quickly now, what it looks like. But I think most of you have already seen a function that looks like this, right? Even though it never crosses the x-axis, it does change its sign. How can this be? Well, this is because of asymptotes. Or, well, asymptotes are basically also a type of roots, or, well, zero, places where the function becomes zero. It's basically if you have a rational function where, well, or a rational or other types of functions that could give asymptotes, but in general they're just irrational functions. Well, in the denominator, if that becomes zero, well, you get this kind of behavior. But that's for later. So let's first start off with our linear function. And here what we are interested in, well, this is our function, and we're going to say, well, we're really interested in knowing where x minus 3 is equal to 0. And we can see, well, bringing 3 to the other side, that this is only true where x is 3. Meaning that we can now write this in a sign table. And a sign table looks a bit like this. So here we keep track of x, and here we keep track of y. You could also say, well, this is the function with this variable x, or you could say x minus 3, whatever works for you, it's all fine. Basically here, as long as you can keep track of x here and y over there. If you want to do it the other way around, why not? But this is in general how I do it. And then we say, well, we have found this 3, so let's already write it down because it must be relevant. So, and at 3, we know that y becomes 0. So now we have neatly split up our function in 2 different parts. Basically the function, how it behaves before 3 and after 3. And for this we can, well, the easiest thing and what I like to do is, well, you find a value on either of the sides which you think, well, that would be easy to fill it into the function and then see what kind of sign we get. And I think 0 in this case is very easy. So we say we get a function and we're going to fill in 0 for that function we had over here. So we say that that's equal to 0 minus 3. So for x, when x is 0, we get that the function is minus 3. And you can say, well, that means that here the function is negative. Then we cross the x-axis and all of a sudden it becomes positive. Of course, you don't always have to go through this. I know that many of you are already very familiar with how linear functions work, how quadratic functions work, and all that kind of stuff. If you know in general how a function looks like, and we'll make many more exercises on this because this is pretty arduous, there are often, well, tricks on how you can really spot this quicker. Well, basically here you can already see that, well, would be a function that rises and that doesn't descend. So then you would actually know, well, it only makes sense if it comes from a negative and it goes to the positive side. But more on that in a later lecture. Then let's also have a look at question E. And I decided to make this one because it has an absolute value in it, and I think, well, we always have to be extra careful with these things, and they tend to be more confusing than the other ones. So we get this over here. And then remember, when you have absolute values, you always have to be, you're always dealing with different types of scenarios. And in this case, well, if x is, let's start first with greater or equal than 0, and then x could also be smaller than 0, well, you're again dealing with two different types of functions. In this case, you get x minus 2x, because it doesn't change, right? Because x is a number greater than 0. And really write these things down because they become relevant once we're investigating the sign. So let's have a look at the other side, and then you say, well, y is equal to, well, now it is a negative value, so basically it becomes negative, because we have to invert the sign, x minus 2x. We can rewrite both of the functions we found over here, and here we find that it's minus x, and here it's minus 3x. Okay, now that we know that, well, let's investigate when these things are 0. So when is y is equal to negative x equal to 0? Well, it's only equal to 0 if x is 0. And here much the same. So minus 3x, when is that equal to 0? Well, it's only equal to 0 if x is 0. Okay, so we only have one potential root. And let's write that already down in our sign table. So we get 0 and then 0 over here. So y and x. Let me move my path a bit. I think that should help driving more straighter lines instead of making them this slanted. Okay, so once we're here on the positive side, so greater than 0, well, let's have a look. And in this case, we're in the first scenario. We're over here. We're dealing with this thing over here. So what happens there? So we have a x that's greater than 0, then we have this function negative x, so it doesn't matter what we fill in for number. Imagine that we say, well, x is 5, then we're going to get a negative function over here. So we find that it's negative, because if we fill this in, function 5 is equal to minus 5, well, we see that our function is negative, so any part over here becomes greater. And here we cannot alternate like we did before, like saying, okay, logically must cross the x-axis, because it doesn't necessarily follow that behavior, because it does not. Absolute values are always a bit more tricky, so you have to really evaluate each of the parts. And here you say, well, okay, what if x is smaller than 0? So then let's say a function of minus 5 in this case. Well, let's fill that in, and then we get minus 3 times minus 5 is equal to 15. So here you can see that it is positive. So this is what our function would look like. And really with absolute values, really always split it up into two parts and then write it in your sign table. I hope this was clear for linear functions. You can of course try to make all the other exercises, but if you followed along with me and tried the exercises for yourself, and especially the one with the absolute value, if you manage, then I think you can move on to the next exercises. I'm not going to assign the other exercises of the first part, well, of the first exercise series on linear functions as homework, because, well, there are more tricky ones that I will later assign you, but if the more tricky ones I assign to you don't make any sense, really come back here and try these kind of exercises and really start with the basics. Okay, then we can move on to question series number 2. And here it becomes a little bit more tricky, but not that much. And here we're interested in, well, quadratic functions. So we get a function, and we'll start with a. Y is equal to minus x squared plus 2x plus 48. And again, well, what are we interested in? Well, we're interested in finding when is this function equal to 0. So where are its roots? And here in this case, well, you can just try with your discriminant. So let's have a look. So our discriminant 2 to the power of 2 minus 4 times minus 1 minus 48. So in that case, we get over here, we get 4, and then we get 192. So 4 plus 192 gives you 196. So that's our discriminant. So then we can say plus minus the square root of 196, which just happens to be very conveniently 14. Nice, neat natural number. And then, well, negative sign of b, so minus 2 over minus 2. Okay, you can work this out then, and then you find two roots. You find minus 6 and 8 normally. Let me see if I didn't mess up with writing over here. So we get minus 6 and minus 8. Yes. Okay. So once you have this, well, you know the roots of your function. And here it's neat. It's just going to alternate again. You get x, and then now let's write it out once completely. It's also just fine to write y. 48, and then we know that for minus 6, starting with the smallest number, going up to the largest number, 8. And we know that that's going to be equal to 0 over there. Now, well, all that's left to do is look within this interval to find a number that's really easy to fill in. And 0 again pops out to me as being very easy to fill in, because then you can just say the function at 0 would be minus 0 squared plus 2 times 0 plus 48. So that gives you 48, which is obviously a positive number, so you can say positive. Because you cross the x-axis and it's not a double root, which you would get when it doesn't happen, we can neatly alternate the signs. So it just goes through the x-axis and it needs to alternate the sign. Of course, some people already say, well, I know here that it's a negative sign in front of x squared, so I know that the function must look like a hill rather than a cup. That's also perfectly fine if you follow that reasoning. Okay, so I'm talking here about double roots. Well, we already kind of discussed this in the last session, but the alternating behavior will not happen when you have a function that happens like this, right? When it just touches the x-axis and it goes back up. So if you ever find that there is a double root somewhere, well, instead of going from positive to negative or from negative to positive, well, in this case, it would just remain positive. So that is a little thing to always keep in the back of your mind. Okay, so that's 2a. Then let's move on to c. Yes, c seems like a good exercise. Okay, so y is equal to 9x squared minus 12x plus 4. And then again, now you can of course use your calculator, so the numbers are always a bit bigger, but on the exam we'll make sure that these are very doable. And here, well, I strongly encourage you again, try and make this exercise along with me. So highest power of x is just a square, so we can immediately go to our discriminant and see if that yields any results. So we get minus 12 squared minus 4 times 4 times 9, which gives you 144 minus 144. So in this case, your discriminant is 0. And that's very interesting because I just did an explanation about, well, what would happen in that case. So please pause the video and try to see for yourself what would happen now. Okay, I assume that by now you've paused the video and tried to find it out for yourself. So let's see what we can do with this. So in this case, well, we get plus minus 0, and then we find some other, well, minus, so we get minus 12 minus minus 12, so we get just 12 over 18. Or we could simplify it a little bit and we find a double root in 2/3. So let's investigate the sign. And we say at 2/3 this function becomes 0. Okay, So again, let's investigate what happens and let's fill in an easy number. And again, 0 seems like a good candidate. If I fill in 0, I get that the function is equal to 4. So it's a positive thing. And here, because you kind of see it as going twice through the same root. So you're changing it to a negative sign and then changing it back to a positive sign, or you're never truly crossing the x-axis. It remains positive. And this is what I was just talking about, because this is a root we find twice, because x1 and x2 are both going to be 2/3. Right? Okay, so meaning that we find that root over here. Try and rewrite it, maybe factorized, and you will see why this makes sense. Okay, so that for question number 2. Again, here, quadratic equations. If you struggle with this, make the other exercises. If this is clear to you, don't worry too much. I'll give you more challenging exercises once we get to them, but really these are the basics and we will use them in all the other exercises today, but also throughout the rest of the semester. Okay, then we can start maybe with exercise 3b. 3b, yeah, that seems like a good candidate. And then here, well, these are higher order functions. So here, basically, we need to use a little bit more of the tips and tricks we saw in the last exercise video. So y is equal to 2x to the power of 3 minus 7x squared minus 3x plus 18. So here, we cannot immediately apply the determinant as we did over here. Well, because we have a highest power of x, which is equal to 3. So let's see if Horner can help us out with that, and let's see if we can simplify it by basically dividing away the right factor. Okay, if we write all of that down, we get something that looks like this. Of course, you don't have to write the positive thing here, I just sometimes forget. Okay, let's try 2. Of course, you can try many others because, well, 18 is divisible by many things. But let's try 2 first. This is, of course, because I've already tried a couple of alternatives and I know this is going to work. So 4, and then we find here that this is minus 3. So we get minus 6, which gives you minus 9, which gives you minus 18, and neatly cancels out the last term. Okay, we can fill in the rest. We can say, well, this is going to be x squared. Okay, so we have already rewritten our function a little bit easier because remember, we're trying to find where this function is equal to 0. And once you factorize it, it becomes much easier to see. So here we can say x minus 2 times 2x squared minus 3x minus 9. So this part we already know when this is going to be 0. Now for this one over here, we can just use our discriminant again. And we say, well, the discriminant is equal to minus 3 squared minus 4 times minus 9 times 2, which is going to give you 9 plus 72. So your discriminant is going to be 81. Meaning that we can find a couple of roots, which says plus minus square root of 81, which is going to write 9. Let's look for our value of b, which is negative 3. So the negative b is going to give you 3 over 4. Giving you a couple of roots, which gives you here 12. So that's 3 or minus 6 over 4, or you could rewrite it as minus 3 over 2. Okay, and now we have found all of our roots, and there are 3 of them. There is this one, there is this one, and there is this guy over here. Well, this. And this makes sense because our highest factor of x was 3. So now we can all pour that into a sign table, and we get something that looks like this. So we say x, and we start with our smallest value for x where we found the root for, so that's minus 3 over 2. Minus 3 over 2, that's going to make it 0. Then the next smallest one we found was 2. And then the next one was 3. Okay, so we can just say, well, that's 0 and that's 0 as well. In that case, well, we can have a look at our negative and positive signs of both of them. And again, let's just fill in one that seems very convenient. And again, 0 seems like a very good candidate. And you will see in general 0, 1, these are always pretty good candidates. Let's fill in 0, and then we find that our function is 18 for when it's 0. And 0 is obviously between minus 1.5 and 2, so the function is going to be positive here. And then we can just neatly alternate them because we didn't stumble into anything weird. There are no asymptotes, there are no double roots, so we just can just keep going like this. Okay. Then we're already going to make the last exercise of this video where we're just investigating the sign of, well, some basic functions, because after that we're going to rational functions and irrational equations and all that kind of stuff. So we get to exercise C in that case. So y is equal to x to the power of 4 minus 5x squared plus 4. And again, well, you see that the biggest power of x is obviously greater than 2, so we cannot just use our discriminant. But here in this case, well, you can be smart and you can say, well, t is equal to x squared, and then you can just apply your discriminant immediately. So let's do that. So you can say, well, y is equal to t squared minus 5t plus 4. If you want to do this with Horner, that would work as well. I tested it for this exercise just to be sure, and it definitely works, but it takes you a bit more time. So you get this thing over here, which looks nice and neat. So now we can do our discriminant. So we get 25 minus 16. That's going to be our discriminant, which is going to be 9. So plus minus the square root of 9, which is 3, minus 5. So for b, that gives you 5 over 2. So that gives you a couple of values, which gives you 8 over 2, which is 4, and here that gives you 1. Once you have this, well, now we have our roots for t, but we're of course not interested in t. We're interested in, well, the roots for x squared. So we say, well, x squared is equal to 4, meaning that x is equal to plus minus 2. Those could both make 4. Or x squared is equal to 1, so that meaning that x could be plus minus 1, right? Maybe I can write a different step here, so x is equal to the plus minus the square root of 4, and then you get this answer, right? Okay, so let's pour that all into a sign table, again starting with the smallest value for x, which in this case is minus 2, then minus 1, then 1, and then 2. And we know that our function is going to be 0 there. Okay, so again, let's look for a good candidate, and again, it just happens to be 0 is a very convenient one. So let's fill that in. So we find 0 gives you plus 4, so plus. And then we can just alternate the signs, because we didn't stumble into anything strange or anything that we have to be careful with. Of course, I'm alternating the signs here because I know and I've thought about this function, I've looked at it and I said, well, this is fine, there are no double roots, there are no asymptotes, I can just safely do this. If you're not sure, it's better to check each of the areas. But once you've looked at the function and you say, well, I can safely assume that it's kind of going to look like that, then by all means, evaluate it as such. You don't need to keep going. Anyways, this is up to exercise series 3. So the third part of the exercises. We're going to start with the rational functions in the following video. See you there. If these things aren't clear for you, I strongly encourage you, before we go to the rational functions, to make a couple of extra exercises on this so you really can follow along, because things are going to get more complicated now. See you in the next video.